Alzheimer's has long been framed as a disease defined by plaques and tangles, a relentless process that chips away at memory and cognition. But new research from Purdue University reveals a surprising twist. Fat-laden immune cells in the brain may play a major role in the progression of the disease. These immune cells, called microglia, are normally the vigilant custodians of the brain. They patrol neural pathways, remove debris, and clear harmful proteins like amyloid beta, acting as the brain's own cleanup crew. However, when these microglia accumulate too much fat, their efficiency is compromised, leaving the brain more vulnerable to damage. The discovery is striking because it reframes the way we understand Alzheimer's. Rather than seeing plaques and tangles as the sole villains, we now recognize that the metabolic state of microglia, their ability to manage and burn fat, is a key determinant of how well the brain defends itself. Fat in these cells is not inherently bad. Microglia rely on fatty acids as an energy source. But when they convert too much of this fuel into stored fat, creating lipid droplets, they effectively weigh themselves down, reducing their mobility and their capacity to clear harmful proteins. It's as if the brain's tireless janitors have been handed a mountain of supplies they can't carry, slowing them to a crawl at the very moment they're needed most. The good news from Purdue's research is that this fat-induced dysfunction is not permanent. By blocking the pathways that store excess fat in microglia, researchers were able to restore their function, allowing these cells to regain mobility and resume clearing amyloid beta effectively. This finding is profound because it highlights a therapeutic avenue that works not by attacking plaques directly, but by empowering the brain's own defenses. Instead of trying to scrub the brain clean after the damage is done, this approach supports microglia in doing what they were built to do, potentially slowing or preventing the cascade of damage that leads to cognitive decline. What makes this discovery even more encouraging is the broader implication for aging and brain health. Lipid accumulation in microglia is not exclusive to Alzheimer's. It is also seen in normal aging and in other neurodegenerative conditions. This suggests that interventions targeting fat management in these cells could help maintain cognitive function across a wider population, not just those with early-stage Alzheimer's. By keeping microglia metabolically fit, energized, and ready to act, the brain can continue to maintain its internal balance, reduce inflammation, and preserve neuronal function over time. This research also adds a humanizing element to our understanding of Alzheimer's. Microglia aren't failing because they are inherently defective. They're struggling under the weight of metabolic imbalance. And unlike permanent damage, this imbalance is reversible. The cells can be restored, re-energized, and return to their role as defenders of neural health. In a field often dominated by grim statistics and inevitable decline, this offers a refreshing message of hope. Even when brain defenses are slowed, they are not gone. With the right interventions, we can empower the cells themselves to fight back, preserve cognition, and protect memories. In summary, the Purdue findings shift the paradigm from plaques and tangles alone to a more dynamic understanding of brain health. Fat-laden microglia are not simply passive bystanders in Alzheimer's. They are active participants, and when their metabolic function is restored, they regain the ability to clear harmful proteins and protect neurons. This opens the door to new therapeutic strategies that focus on enhancing the brain's own immune system, promoting resilience, and ultimately providing a more hopeful vision of prevention and treatment. Alzheimer's may be challenging, but with research like this, it is increasingly clear that the brain has the capacity to fight back, and that even the smallest cellular interventions can make a profound difference.